Hello, everybody. So today we are going to be talking about atomic mass units. So you are going to scroll to the post that says 925 atomic mass unit. So we have the link for the reading, we have the practice questions, and we have my email that you send them to. So an atomic mass unit, why we use it is for a similar reason as to why we use the light year. So in measuring distances in space, we use the light year because if we were to measure, let's say in meters or kilometers or miles, we would be using very large numbers. Now, atoms, on the other hand, are very small. So their masses are very small. So that is why we use an atomic mass unit, because if we used grams, we would be using very, very teeny tiny numbers. So an atom of oxygen-16, so the most common oxygen atom, is going to have a mass of 2.66 times 10 to the negative 23 grams. Okay? So this is a very, very tiny number. When scientists were starting off making masses or determining masses of atoms, they used the hydrogen atom. Okay, but now they are using the carbon-12 nuclide as the reference standard by which all other masses are going to be determined. So one atom of carbon is going to be assigned a mass of 12 atomic mass units. So this is a 12th, the mass equal to 1/12 of the mass of an atom of carbon-12. Okay, so the mass of any isotope of any element is going to be expressed in relation to that, to the carbon-12 standard. Okay, so one helium atom has a mass of 4.0026 atomic mass units. One sulfur atom, sulfur-32 atom, has a mass of 31.972 atomic mass units. Now you'll notice these are not whole numbers, and that is because we're taking into account the reactions of the particles, and we're taking into account the slight mass of electrons. But for simplicity's sake, when we start going into atomic mass, we round it up as a whole number. If the number after the decimal point is 5 or more, we round it up. If it's 4 or less, if it's less than 5, we are going to round the number down. Okay, it's just easier to use whole numbers. So since the nucleus houses most of the mass of an atom, one atomic mass unit is going to be equal to the mass of a single proton or the mass of a single neutron. Okay, so make sure you do your questions and turn them into me.